Hello, Dr. Alvaro. This is Noah Demoulin,
And Sebastian DiPietro.
and we're here to show you our submission for assignment bonus 1. So, as you can see, we have our scene from the Atari 2600 fishing game, and as you can see, we have some lovely fish swimming around under the sea. As we see, we also have a fishing rod, so we can move the fishing rod around. The fish are rotating around here, and as you can see for a second, and I can just turn it back on, we also have frame buffer objects working. I will record another video once I get that working, but we're in a bit of a hurry because Seb has to catch a bus, so I'll just implement that afterwards and show you how I did it. Alright, so as you can see, we've made it so that the rod is fully movable. And as you can see from the lighting effects, there's quite a shininess to it, and that is because we have implemented falling lighting. So to show that, we have the fish that are very specular. That means how shiny they are. We have sort of a brighter ambient color because the fish are kind of emitting light based on the reflections. Or sorry, not based on the reflections. They're kind of emitting it themselves. And then, of course, we have diffuse lighting, which is good for the color. Alright, quickly demonstrating how that would look without it. Let's just take away specular and ambient, and run that back up. And you can instantly see that the fish are a little bit less interesting, and that's due to the lack of specular and ambient lighting. If we were to get rid of diffuse, it would seem a little bit more muted, and if it weren't for the ambient light, it would look pretty much void of color. Alrighty, so Seb, because you have to go catch a bus, do you want to show us what you did?
So I'll show off some movement. So the movement we did here was with the rod. It was setting up some booleans, some if statements. So here we have the switch statement. When W is pressed, W equals true. Same goes along with S and A and D. The implementation of each direction is in these if statements. So if W equals true, it'll move upwards in the y-axis, and if I wanted it to move down in the y-axis, then I'd use S. If S equals true, then it moves negative y. And the same goes along with the A and D. They move left and right in the z-axis. And for the fish are using, they're rotating around a point. They are shown over, just one second. They're shown right here. So we set the rotation angle of each fish and vary it up between each one so they seem almost in a random movement.
Do you want to say how you put them in the first place?
Yes, so loading in the objects, we would initialize them through here using the rod mesh that we created, the fish that we created, and
then initializing
them to the scene.
into the scene. Yep. As you can see from our folder, we're loading in some OBJs here, which is the fish and the rod OBJs, and those all have different vertex and normal data applying to them. This is not a really great formatted document, but at the same time, you can see that it has different coordinates basically, and in the graphics pipeline, as we're going to do it, basically the first thing we do is load in the vertex data, then we load in the primitives and assemble the triangles basically to load these new meshes, apply in any any textures to the UVs that then get made into geometry shaders, and then at the end of the pipeline, then we're ready to go, so to speak. All right, we're going to cut that, I bet, because it is 9:41 and the buses leave at 10. So thank you, Seth, and I will be back to describe a little bit more on the coloring and the frame buffer objects which we got working.